It's 2:58 p.m. A warning bell rings through the hallway, and casual conversations immediately turn into a frantic sprint. Teachers grab their coffee mugs and notebooks, realizing they're about to be late for the 3 p.m. teaching development meeting. The real source of their panic is sitting in their inboxes. It's a dense, 50-page attachment from the Education Bureau, detailing a critical bilingual teaching plan. It was sent out yesterday, and absolutely no one has had the time to read it. So 3 p.m. hits. The teachers slump into their chairs panting, and the room goes completely dead silent. The first 30 minutes of the meeting are entirely consumed by attendees desperately scrolling through the massive document on their phones under the table, trying to figure out what they are supposed to be discussing. A meeting where everyone is reading materials on the spot is a failure of information flow. It consumes 30 minutes of productive time before a single decision is even made, leaving the staff exhausted by the time the actual work begins. To fix this recurring failure, teacher Nico steps in to propose a systemic software solution. She outlines a highly specific AI agent designed to bridge the gap between heavy documentation and human attention. She calls it the Teaching Meeting Guard. The concept is straightforward. Instead of relying on humans to remember to read documents, this digital assistant links directly to Google Calendar and is programmed to wake up exactly 15 minutes prior to any scheduled meeting. Once awake, the guard begins its data gathering phase. It automatically scans the meeting roster and hunts backward through the system, pulling all relevant email threads and cloud drive attachments generated over the past week. This flowchart shows the final synthesis step. The raw, scattered data is fed into a generative AI node powered by Gemini. The AI condenses those dozens of pages into a highly structured, single-page summary and pushes it directly to the attendees' mobile devices. Automation adds value by delivering precise context to users exactly when they need it, allowing them to read a distilled briefing while they literally walk to the meeting room. Building this starts in Workspace Studio. The initial setup phase is simple enough. Set the starting trigger to the Google Calendar event and lock in that 15-minute lead time. The digital alarm clock is set. Next comes the logic. The user starts stacking commands, creating a single continuous chain. They add a step to get the calendar details, a step to search Gmail for the event title, and another step to query Google Drive for matching files. The workflow grows longer and longer. Finally, all that retrieved data is routed into the AI node using the PTCF framework, providing a clear purpose, task, context, and format. The command instructs the AI to act as a meeting secretary and output a structured pre-meeting summary with key topics and critical deadlines. The logic is complete, but when the user clicks Save, the system completely rejects the entire massive workflow. A harsh error prompt appears, step limit exceeded. Cramming every single command, searching emails, parsing rosters, querying attachments, and generating text into a single workflow overloads system resources. It hits the strict architectural boundaries designed to prevent any one process from exhausting server capacity. To solve this, we have to look at this diagram, illustrating a core computer science principle, modular decoupling. Instead of building one massive script, we resolve the system limit by breaking it apart into smaller, conceptually chained flows. We start with Flow A, data collection. This module runs silently in the background every night. Its only job is to find emails regarding the bilingual plan and apply a specific custom tag to them. Then we build Flow B, attachment organizing. This operates completely independently of Flow A. It pre-sorts relevant documents and consolidates them into a designated pending meetings folder. That brings us to Flow C, the guard. When the 15-minute calendar alarm goes off, Flow C doesn't have to search a vast database. It simply pulls directly from the specific tag and the pre-sorted folder. By letting flows A and B do the heavy lifting beforehand, the main trigger flow, Flow C, drops to a highly efficient 6 steps. The user clicks Save again, and this time it succeeds instantly. Scaling complex automation requires a shift in engineering mindset. You stop trying to build an omnipotent giant, and you start orchestrating an army of specialized microflows. With the modular workflow in place, the system executes a flawless test run. Because the data is already pre-processed, the guard reads it incredibly fast, pinging the user's phone precisely on time with a perfectly bulleted AI summary. The next day at 2:45 p.m., the reality of the workday looks entirely different. There is no sprinting, Teachers take an elegant stroll toward the meeting room, coffee in one hand, reading a concise review of key topics on their screens. Inside the room, they skip the 30 minutes of catch-up and speak directly to the core issues. The meeting hits all of its required agenda items and concludes within a record 30 minutes. The back-end design of these flows is what determines if a Tuesday afternoon feels like a crisis or a routine check-in. By shifting the work to background processes, the school recovered an hour of collective focus every single week. Decoupling complex tasks into smaller, interconnected flows is how you build scalable AI automation. It keeps your logic clean, your systems fast, and your operations strictly within architectural limits. If you found this breakdown of modular architecture helpful, be sure to like the video and subscribe to the channel so you don't miss our next deep dive into Workspace Studio. We will need these architectural principles soon. The end of the semester is approaching, bringing a flood of chaotic, unstructured digital form requests from students, everything from broken air conditioners to missing pond turtles. To tame that hodgepodge of intentions, we'll have to build something entirely new. Join us next time as we deploy advanced decision logic branches and cross-system webhooks to automatically route complex requests across an entire organization.